today's video, we are going to start taking a look at our periodic trends. So our periodic trends are atomic radius. That's what we're going to focus on in today's video. Next video is going to be ionic radius. Then we also have ionization energy and electronegativity. So in each video, we will be talking about what those things are and how they change very systematically as you either move across a period or down a group on the periodic table. For most of those, for everything other than ionic radius, we are going to be able to look them up on table S in our reference table. So most of your trend questions you can answer correctly if you take the time to look them up on table S. So let's get started with, we also will be talking about reactivity and how things react differently depending on where they are on the periodic table and how that changes as you either move across or down. So we're going to get started with atomic radius. So a radius would be, from the center of the circle out. So it's difficult to measure just one atom. So it's better measured in a diatomic molecule. So it would be half the distance from nucleus to nucleus. And very important, atomic radius is given on table S in picometers. So given on table S, so we can look it up on table S. And it's given in picometers because our atoms are tiny. So we need a tiny unit to measure their radius. All right. So what we're going to do is first look up the atomic radius of something at the beginning of the group. So we're going to do lithium and the bottom of the group. So lithium and francium, and then we'll be able to see for ourselves what happens to the trend. So on table S, you look up the radius for lithium, and lithium is atomic number 3. We go all the way across. It has a radius of 130 picometers. All right, and lithium again is right there on the periodic table. Then we look up the radius of francium. Francium is atomic number 87. So 87, go over, and its radius is 242 picometers. Francium is right there. So we already know what our trend is. As we move down the group, the radius obviously increases since the numbers are going up. So our atoms get bigger as we move down the group. Now we need to talk about why. So the reason why is because their period number equals the number of electron shells. So if we take a look at lithium, lithium just has 2 electron shells. Francium is in period 7. So francium would have 7 electron shells. So francium has to be a bigger atom since there are more electron shells. So as you move down the group, each time you go down, there is 1 additional electron shell. Therefore, the valence electrons are further from the nucleus, which will result in a larger radius. So now we're going to do the same thing, except we are going to look at how the radius changes as we move across a period. So we are going to start by looking up the radius of potassium and then of bromine. So again, on table S, potassium is atomic number 19, and that has a radius of 200 picometers. Bromine, atomic number 35, that has a radius of 117 picometers. So we see that as you move across, the radius decreases. So as we move across the periodic table, within a given period, the atoms actually get smaller in size. So now we need to talk about why that happens. So the reason why that happens, if we take a look at potassium and bromine, they both have 4 electron shells. So they're in the same period, so they contain the same number of rings around the nucleus. However, so let's draw potassium. 1, 2, 3, 4. Bromine also has 4 electron shells, but its electron shells are closer together. And we know that the electron shells would be a full circle, but I'm just drawing a half circle to save space. So what happens in bromine is bromine has a stronger nucleus. Potassium has 19 protons. So 19 positive protons pulling in the negative electrons. Bromine has 35 positive protons pulling in the negative electrons. So bromine has a stronger nucleus, so it is better able to pull the electrons in. So it sucks the electrons in to make for a smaller atom. This is the trend that people tend to have trouble with because the mass is increasing as we move across the table. So sometimes people automatically assume that the atoms also are going to get larger in size, when in fact, their radius decreases because more protons in the nucleus can better able pull in those negative electron shells. So it's like bromine is a stronger magnet and can suck those electrons in a little bit tighter. All right, so now we have our examples. All right, so now we have our examples. So with our examples, we can certainly use our trends to help us, and that will definitely save us time, but we should also be checking our answers on table S to make sure that we are getting the correct answer. Because if table S gives us the radius, it should make these questions super easy. So for number 1, we want something that's in decreasing order. So we want it to go larger to smaller. All right, so we could do this with the trends. So looking at our periodic table, we got aluminum, silicon, phosphorus. We get smaller as we move across. So that should be our answer. But we are good little students and we check our work. So then we go to table S and we look at them real quick. Aluminum is 124, silicon is 114, phosphorus 109. So that confirms that we do have our answer correct. If we took a look at our other ones, they would not be correct. So lithium, sodium, potassium would all be getting bigger because they're gaining electron shells. So potassium would be the largest. Same thing with choice C, chlorine. Bromine would be bigger than chlorine. Iodine would be bigger than both of them. So that's not correct. And D is also not going to work because boron would be the largest of those 3. All right, number 2, what is the radius of calcium? Clearly, we have to use table S to get that answer. So we go to calcium, atomic number 20, and its radius is 174 picometers. All right, SR. So we keep going down the table. SR is atomic number 28, and its radius is 190 picometers. All right, now we need to explain why SR has a larger radius than calcium. So now if we flip back to the periodic table, look at where they're located in relation to each other on the periodic table. So they are in the same group, but SR is below calcium. So if we look at their electron configurations, we see that calcium has 4 electron shells. So calcium would have 4 rings around its nucleus, and Ba is in period 5, so it has 5 electron shells. Therefore, Ba will have a larger radius. So if Ba has 1 extra shell, it is going to have a larger radius. So you could have just said that Ba has 1 extra electron shell.